Very glad to be here. It's always nice to visit Singapore. Silent push, just so you know, so we map threat actor infrastructure before it's used, and we share that with our customers. We're the fastest growing threat intelligence company in the world, and the only one that hates threat intelligence. So we're controversial. um, through all our years of defending customers through the different companies that we've been in, we've always been on the detection engineering side of the house, really. And so managing different detection products. One thing that always frustrated us was threat intelligence. Or that department over there who claimed they knew stuff, but none of their information ever helped us to defend anybody. When we were managing blocking products and stuff. So the truth of the matter is that on any given day, the security industry is only aware of what is hitting the customers, not what is about to hit the customers. And because threat actors now move through their infrastructure so fast, there's just a huge amount of unused infrastructure about to hit you that you don't have, because all threat intel is post breach information. It's like information shared after something has happened. So it's really not great for preemptive detection. So we've taken it upon ourselves to, make the new science of pre-attack TTPs, of how threat actors manage their pre-attack infrastructure, and we monitor all changes on the internet in order to find their different management patterns, so that we can enumerate it every day and share that with customers, right? However, we also share the underlying data for free with everybody in the security community, right? Including our risk and reputation scores for all infrastructure. So this is really about moving people from historical information onto preemptive threat intelligence and what we call indicators of future attack, which is what is still unknown to the security industry, right? So we're trying to get people from reactive defense to preemptive defense and get you ahead of the game. Now, in terms of how early you actually see stuff, it's very different depending on the type of threat actor and the type of infrastructure that we're looking at. So, with some of the annoying kind of younger groups like Scattered Spider, they're just standing stuff up and taking it down within minutes or a couple of hours. So that's incredibly painful, and you can only give so much time ahead of that being used. But then with some APT groups, they're aging their infrastructure by a year. So we're actually sitting looking at it for an incredibly long time before it's used, right? And that is also shared with our customers all the time, right? Like we have a lot of, very real world stories about, detections that were, sometimes great and sometimes embarrassing for people. Like we were in one small country's security agency, and they were going through our what we call context similarity, which is where we automatically say what something is likely to be if you give us like an unknown, based on how it was managed pre-attack. And that particular country said, "Oh yeah, tell us what this is," and them knowing full well it had never been used, right? And we said it was Pegasus 4 from the NSO group, and then they all went white, right? Because they were actually the customer of the NSO group about to deploy it, and we already knew what it was before it had been used, right? It's a very, very effective way of doing things. So I'm going to give you insight into how we do those sorts of, pre-attack behavior detection as to how people are managing their infrastructure. And then we'll show you a very simple example, but it's a very big example of infrastructure that we can clearly see on a daily basis, without us really having to do a huge amount of work. So we're monitoring all technical relationships on the internet on a daily basis, right? So we're a very greedy data collection platform, and how we manage that information is very important. Um, we look at everything with these kind of three vectors. So changing relationships in DNS is always a key critical one for us. So that means we have to force re-resolutions of all DNS records on a daily basis. We cannot use passive DNS for this, right? So we can't use services that provide passive DNS because that's too late for us, right? Because those services only detect stuff after there's traffic. So that means we have to force re-resolution so that we can see patterns before the infrastructure is actually used, right? I'll give you clearer kind of ideas about why that is in a minute. Then we're looking for infrastructure changes. Is there a server up on the end of that A record yet? And if there is, does it change? And then we make different fuzzy hashes of the server responses and stuff. And then finally, content changes. Are there actually any panels or anything on the end of that that identifies it in any way? Even custom error pages are actually pretty useful for us, right? So the service really involves us doing these different layers of data manipulation, right? So first of all is our collection layer, right? So we scan everything in a number of ways. So we scan by IP, we collect certificates, we also scan as every host name that we discover. We obviously have the force re-resolution of DNS records, and then we have a number of little feeding mechanisms to keep feeding that re-resolution pipeline from other places to keep it going. Now, those things on layer one, so to speak, that's like, you have bought a bunch of different data providers, right? So it's like you're buying, a combination of, Farsight and Census, all the different kind of data providers. But we make all the information ourselves because you actually have to collect all of this in a very specific way if you're looking for threat actor infrastructure. So, for example, when we're scanning infrastructure, we don't publish the IP addresses that we scan from, right? That's considered good internet etiquette, is to publish the IP addresses that you're scanning from. But obviously, the threat actors just block it, right? So, if I wanted to show everybody where all the webcams and fridges were, that would be a great way to go. But we want to find threat actor infrastructure, so we don't tell people where we're scanning from, right? Seems obvious, but that's actually not how most people do it, right? And then sometimes we actually have to get pretty inventive, and use different sorts of proxy networks and even residential proxy networks in order to be able to scan certain infrastructure as the threat actor expects the data to go from, right? So in previous roles, where we were running kind of sandbox infrastructure, we were just continuously blocked by the threat actors because they've made a phishing page, they expect it to be accessed from a mobile device in whatever country, and it's coming from AWS. They're like, I don't think so, right? So they've got very simple mechanisms in place to handle security companies on a large scale in many different ways. So a lot of our behavior is pretty kind of odd for a security company to be behaving in this manner to make sure we see what we need to see. The second layer, though, is really what's critical in terms of what matters to enable us to see and track stuff early, right? And that's change detection. Each of those data points is relatively uninteresting on its own, right? It's like any lookup service, you can scan a piece of infrastructure, get a fingerprint. So you could do that with Showdown or something at the minute, right? It's like the static information is not that interesting because if you want to actually identify the process that someone is following when they manage their infrastructure, it's change detection is where their actual process reveals itself. So we have to make an awful lot of information that is change detection. And I would liken the kind of difference between column one and column two is like, when you're in school and suddenly your maths class switches from algebra to calculus, right? Some of the kids are kind of left behind, right? And this is how it is with cybersecurity. Some of the companies are kind of left behind because they don't get the concept that the straightforward scan only gets you point in time information. While if you are actually looking for someone's management techniques, it's understanding change information is actually what gets you people's tactics and techniques of how they manage their infrastructure, right? So it's very key, the middle layer, to understand change detection of all technical relationships on the internet every day, right? And to have the full history, because this is where people really reveal themselves, right? Uh, and then on top of that, we build, different. We're looking for different patterns. We cluster it in different ways. So, some of that is machine learning, some of that is human, depending on what we're involved in. But finally, at the end of the day, it lets us discover what we call indicators of future attack, which is, a group of behaviors is producing these things on a daily basis, and then these things, are all part of a particular campaign or threat actor's infrastructure, and it works to a pretty dramatic extent. Uh, in terms of the information that's important for timeline of detection, so to keep your information really early, it's the relationships in DNS is way more important than anything else, right? Because the DNS happens first, and the DNS is where people reveal their automation before anything else. So, let's say I'm threat actor ABC, first day in the job in a big new threat actor organization. They're teaching me how to manage my domains. So they'll tell me, we buy them here across 3 different registrars, then we move them here. So, from our security point of view, I'm thinking, all right, that's a name server change, right? We're going to see a name server change in the DNS records. I'm going to say we rent subnets across 15 different hosting providers, and every domain that we set up, is going to rotate across those, because that's how you evade other security products. They can't block your IP address, etc. Right? So that'll be an example of a combination of behaviors that very quickly becomes a definite fingerprint, because the chances of someone else, having rented the same 15 subnets across a whole bunch of ASNs is pretty unlikely, right? So, once you see a domain moving through, let's say 4 of the 15, you're probably past a point of no return where no one else is going to match the pattern already, right? And they will have done that before they've actually put up any, malicious pages or infrastructure or anything, right? All of that's set up well before there is anything. So that's why relationships in DNS is always critical in terms of us being able to map this type of infrastructure, right? Then we're watching for what's going to go up there, right? So infrastructure change is then important, because what type of server appears there, and then whether these guys, they may always like set up a default server from the provider or something when they set up initially, and then they change it to something suitable to whatever they're going to throw up later in the process. So again, we'll have like change detection that matters and gives us an indicator of what's going to come. And then on the end, we will be checking content all the time, because we fingerprint everything on the content side, including JavaScripts on the pages, security or certificates. We make certificate hashes, all kind of different fuzzy hashes we make of the content, so that we can actually search for similar content elsewhere. We also do honeypots and stuff, and we fingerprint inbound scanning to give us context on other IPs as well. Hope everybody was able to follow what I was doing there. So the critical thing is that, now you're able to like enumerate the threat actor infrastructure as it approaches its live stage, and you can share that with people, right? While you know that, the actual public information about this stuff will only be revealed after it hits its first victim. So you get an incredible head start on a lot of this infrastructure that you can help people to block. So this is a very large crime group, Triad Nexus. So, I'm sure everybody here knows this group really well, right? whatever it's referred to as locally. But this is Chinese triad groups who are running the fraud farms across Southeast Asia, operating pig butchering and other scams, right? Fake trading apps, etc. Um, it's an enormous crime infrastructure, um, and this example is gonna show you one of the kind of simplest ways we can track people, but there's like hundreds of ways that we do this, right? So we're just picking out a very simple example that has quite a large impact. So we call some of these things fall into a category that we had to make up, right, to suit what we do, called infrastructure laundering, right? So infrastructure laundering is where they're trying to use like high reputation hosting providers, and they put a malicious CDN in the middle between the crime and the actual IPs they're using. So, they want to use Microsoft and Amazon for large scale crime. So they have this complex CDN that they run in the middle to keep moving the infrastructure at a rate that the by the time a crime is reported and then it goes to the hosting provider, it's long gone off that infrastructure anyway. So there is no takedown to be done. So it's a very kind of annoying and frustrating technique, I think, for the infrastructure providers, right? Uh, like this is an example of, so this fake Goldman Sachs trading platform has been live since last September. Uh, it's part of this malicious CDN. This is something you get sent to if you're part of like a romance investment scam or whatever, right? And they're telling you where to put your money, and they put it in this fantastic, legitimate Goldman Sachs banking application, right? But obviously, it's not. Um, and the survival of this is something that is like pretty shocking. Uh, a lot of this infrastructure is like really well done in terms of it's localized for the market. They actually farm these out to affiliate programs as well. Um, they have online support, etc., as you'd expect. They have a mobile app for them, so it's very convenient. So that's been on our thing since whatever that was, 22nd of September last year. Uh, it's like still undetected, right, by uh, the general security industry, right? Even though it's been live all that time, and completely just allowed to operate, right? So the success of these crime groups at keeping their infrastructure up through their infrastructure laundering techniques is quite incredible, right? Um, so that's the fake trading apps is one part of what they do. So we'll expand on that in a minute. So this is very much, they do fake trading apps for like genuine banks, and they do crypto exchanges, right? Fake crypto exchanges is part of their same, let's say, one of their columns of crime, because it's a huge crime group. They have many, many. Um, so in order to map this as it's prepared, um, you know, from the point of view of like local law enforcement in most countries, when they're trying to handle this, it's like an impossible task, right? Because it actually goes to local policemen. Like somebody comes to them saying, I've lost all my money through this scam that's been going on for months, through a dating app that I'm on. And so the whole thing only sees the one fake page, and it's so slow to even, be discussed. And that local law enforcement has no capability to actually deal with this in any sort of a real way. So it's very, very hard to deal with, right? Singapore has a better track record than other countries of trying to deal with this stuff, right? So there's been a lot of stuff revealed here where they went after the money laundering side of this operation, right? This is from one of those Singapore-based reports, right? Followed like the human side of it, which was incredibly complex. and we follow the kind of technical side of it, right? And this is also complex, but when we kind of reveal it to you how it's managed, it starts to look a little bit simpler, right? Even though it's very large. So that's the Goldman Sachs one that we were looking at, right? And you can see it's moved through those IP addresses, right? And then the one in gold is a CNAME record, right? So the same CNAMEs that you would use to redirect your www.abc.com to abc.com, which has its A record, or if you signed up to something at HubSpot and you wanted to rebadge it as your own name, right? You'd use a C name to point it towards like HubSpot abc.com, which is yours, right? So that's the C name records we're talking about. But in this case, they use it to manage all of their crime infrastructure in a very, very neat fashion, right? It probably seemed like a very neat fashion until we started mapping their infrastructure by the neat fashion that they were managing their infrastructure in, right? So this particular one, you can see this fn03.vip, whatever the subdomain of this CNAME record is. If you do a reverse lookup on it, you get this 1,000 odd different host names that are going through it, right? All of those are a different fake trading application, right? So this one CNAME record has over 1,000 fake trading applications, right? This is all the CNAMEs within this cluster of crime. So each of those CNAMEs has a cluster of crime infrastructure like that, right? And then when you actually multiply it all out, it becomes 1.4 million malicious host names, right? So that's the size of this part of their crime infrastructure, right? It's like truly enormous, right? And the amount of money that they are getting, globally, and they rent this out through affiliate programs as well in other parts of the world, right? So it's like it's hitting everywhere, and there's just money leaking back to these guys through this infrastructure, which they seem to be able to keep up for endless amounts of time, right? Without anybody interfering with them. So the CNAME records, to explain what they've done with those, is they've actually put different crimes, filed by CNAME record is what they've done there. So each of those CNAMEs represented a different variation of a different crime. And they have, this whole bunch of different crimes going on all the time. Some of it's for money laundering, because they also provide money laundering as a service to other crime groups through fake betting apps and stuff, right? The odd thing is that, anywhere there's crime, all of the providers who are involved are actually beneficiaries of the crime, right? So, the infrastructure providers here are benefiting from the money by that crime group, right? Because they're getting paid for hosting services from that crime group. So, that's one of the places we can try and hit to have impact, is embarrass them. So, we've been doing that pretty heavily. So, one of these providers acted very well and went after them. Another one, just came after us with their PR. They responded to all our takedown stuff with their PR department, right? Not like an abuse team or anything. It was like their PR department and then their legal department, right? So they obviously didn't want to know about it, right? But the very clever thing as well about this is that they have their infrastructure moving between non-collaborating countries all the time. So it's going over to the US, China, etc., back and forth all the time, right? So any page is like going back and forth between these different countries that don't necessarily collaborate on doing stuff. Originally, we were approached by the financial institutions about this problem, right? But then, because we had written about it, then victims started contacting us. So that wasn't great, honestly. There's tragic stories. It's just like endless tragic stories, and there's so many. It's ridiculous, right? It targets all sorts of known brands, and that kind of reveals the regions that it's targeting and the affiliate programs that it has in place. So, there was New York there with this is BNP Paribas, that's the Japanese exchange. There's really no limit to it. This CDN is called the funnel CDN, and they keep popping up in different ways. But it's actually part of another organization, which we'll hit in a second. But this funnel crowd popped up and made the news a lot early last year when they took over the polyfill domain, and then they started redirecting stuff to their gambling sites and stuff using that. But if you look them up, they appear to be from every country, right? So they claim to be from Slovenia. They claim to be made in the USSA. In the USA, sorry, their WeChat numbers in the Philippines. The underlying language and Telegram profile is Mandarin. Uh, there's just an endless amount of rubbish, right? Rubbish information. But it's actually advertised under a group called ACB Group, and they advertise this CDN as one of the products that they deliver. So on their homepage, you can see them claiming funnel. It's they've actually got rid of that, right? Some of the customers and crimes are worth taking a look at. So this is their retail focused crime. You can see there's again a good kind of uh, global variety of countries involved, right? So you can see Lotte is there, right, from Korea, as well as others, but they really have a very broad range that they go after. Obviously, the fake trading app is a pretty common one. Um, there's also fake online tech, right? So this goes after Amazon, TikTok. OTX is like an online marketplace in some countries. Um, yeah, they've fake meta stuff and others, and this is pretty popular crime. Actually, there's a I don't know if the TikTok team are here, but uh, the TikTok is like really heavily targeted by them, and they do a lot of work. We've had a lot of back and forth with TikTok about it. So they were able to share a lot of information with us about how the scam that was targeting them worked, as opposed to the others. And then they had actually found out some stuff about those mobile apps that we didn't know as well. So often threat intel teams in the different companies do great work together, and maybe better work when they work together. And I think our work with TikTok is one of the ones that really benefited both of us enormously. They also have fake streaming applications. That's a typical pattern. This is like a what we call an IP diversity pattern. So it's like the movement of a domain across IP space. So you can see them; they're moving between Amazon and CTG servers, which is in Hong Kong, I think. Um, they obviously have fake VPNs and they have adult services. The polyfill domain was them as well. If anybody remembers that, does anyone remember the polyfill thing last year? Yeah. Um, so that they bought that domain name off the guy who used to manage the um, open source software for polyfill, and then so it was like a JavaScript that you would put on your page, but they just adjusted it to start redirecting everybody to their gambling pages. But luckily, Namecheap shut it down pretty quick when it happened. And then they've this enormous amount of offshore gambling, and a lot of that is actually pretending to be the company, or at least that's what the companies have told us, right? I don't know, but yeah, it does seem to be fake. Um, so a lot of this has been uh, reported on in quite a different way by the United Nations Office on Drugs and Crime, right? And they've done an update on this as well. Uh, but it's obviously a huge problem, and I think we seem to be the only ones who are looking at the technical aspect of it, right? Because it's always interesting to us, the convergence of real world crime groups and their cyber operations, um, because I think that's ultimately where things are going. Uh, it's the kind of real world crime groups have decided that they should be the ones partaking in cyber criminal operations, and they're not going to take no for an answer. So when they're doing things, they're quickly becoming these enormous scale types crimes that are hard to believe that it's so big. So you can actually try this yourself. So we have a free community app that people can use. So if you don't have our thing, you'll be able to sign up at our booth, or just scan the code, or go to our website. And then when you're in there, you can do these reverse CNAME lookups, right? So maybe write that one down: app.amazons-ap.com. That's one of theirs. And then when you look at the CNAME tab, you'll see they have these two CNAME records. And then you just click on that and do a reverse CNAME, and that will show you everything that's pointed at that one, kind of give you the hang of how that works, right? So that's kind of the simplest version of following someone through their DNS records. But it's a pretty good way. You can monitor what they set up every day as they set it up, and know what's coming for you. So like we do this, we're obviously on the road a lot doing this, and you any day for any kind of country or region, you can just pick up, oh, here's the stuff that these guys have set up for you today, because it's just, there's so much of it, right? So just to kind of, for this example, kind of give you an idea. So easily enough, you can just like pick a crime and expand out into, we went from one thing to 1.4 million host names, in a way that we can monitor on a daily basis and just provide everything that these guys set up every day, even before they use it, right? Now with this one, we do a lot of work with international law enforcement, so they can also see it. But I think this crime group is a certain type of crime group. We also follow, though, the APT groups. The North Koreans were in their stuff all the time, and initial access brokers are pretty key as well to monitor, right? So if we still stay in section 1, where we're still looking at relationships and DNS, right, and take another example. So we have this kind of complex part of what we do, called domain search, where you can combine all of the types of behaviors when someone is managing their domains. So this is the one where you have, like, you can put in all the different hosting providers that they're using, name servers, registrars, like all sorts of combinations of what they're doing, and do a search. And then once you have that, you can provide it on an automated basis every day, when these guys set stuff up, right? And again, you can see that kind of running and hiding the IP diversity pattern, as we call it, right? Raspberry Robin is a very important one. So Raspberry Robin is an initial access broker and sells access to all the ransomware operators and different crime groups now, right? So they didn't start off like that. It's been quite an evolution of Raspberry Robin, but Raspberry Robin's actually really easy to track, right? So they have these very specific domains that they set up, and then they are popping NAS boxes, right? On, could be on home networks or wherever, right? But they're popping NAS boxes, and then that becomes their botnet. But they manage it all through DNS. So it means that we have these particular domains that follow a pattern. So we can put in a regex search, and then we just look for those combinations of how they move across IPs and hosting providers, and it actually falls out every day, right? You just get the list of Raspberry Robin stuff every day. So it means you can, because it's way more important, to monitor the initial access brokers than anyone else in the kind of kill chain, because these are obviously the guys who get everybody in the first place, right? So this is the stuff you want to make sure you're blocking. Um, so another one that pops up a lot is different types of name server changes. Name server changes can be important for many different types of reason, right? So, much like years ago, security products, we would have started scoring stuff based on, a new domain. You'd give it a high score, pretty risky to let it through your traffic, right? We actually do the same with name server changes, right? So we would consider name server entropy like a real sign of instability in online infrastructure and high risk. And then certain types of name server changes are more high risk, right? So if you see name servers changed, from, someone that we already don't like Najala.no or something, that's a provider up in, I think they're in Norway or somewhere, right? And you see it switched to self-named, meaning that the name server is the same name as the domain. Like, we would consider that a high probability that it's going to be malware related, because it means that the malware they deployed needs to communicate with its own name server, where it's going to be providing TXT records, etc., on the fly. So they have to be operating in the same way, right? So, back the SolarWinds one, they had self-named name servers. It's a common thing that we look for. So there's a lot of these patterns that I guess we would initially know from experience to look for them, but when you look at them as well as combinations of the other things, becomes. I hope you were all expecting us to go into this much technical detail. No one's shocked, wishing they'd gone into a different room. No, so it's a very good way of tracking different groups, right, and campaigns. If you look at section 2, we can actually do the same with header servers. So we hash all header servers in a very specific way so that we can catch things that were set up in the same way. And that gets us like so much crime infrastructure, you wouldn't believe it, that we know it's set up in a certain way. So I want to have questions, so I might skip the last couple of examples, right? But we can also do page similarity, right? So HTML similarity search to discover different phishing templates where, they use the same template, but it's like loads of different brands, and we can pop it all up that way, right? But you can also combine your searches across ClearWeb and Tor, right? So this is Dragon Force. So we can do the search for Dragon Force and the header powered by across both .onion and ClearWeb at the same time, and pull up each version of their thing. We used to do that for Lockbit and others as well. So you can combine lots of different types of data sets that we have into these searches. Again, that is actually available to everybody on our free community app, right? It's one for everybody in the audience, right? So with these, we make what we call TLP Amber reports, which is a full explanation about how this threat actor manages their infrastructure, how we track it, the queries we use, the underlying data, so that we coach everybody in how we do what we do, right? And of course, to the enterprise customers to get the finished indicator of future attack feeds to block. So it's worth considering, can you get indicators of future attack into all your security products and get earlier detection, and try and change your mind from reactive to proactive. We're part of the Cybercrime Atlas group, which is hosted by the World Economic Forum, where we provide both our platform and our analysts to law enforcement to help stop these types of crime. Before Christmas, we had 1,000 arrests in conjunction with Afridpol for what was essentially affiliate programs of the crime group that we looked at before. So we try and do what we can there. That's the QR code for the free community edition if anybody wants to play with what I was talking about. Any questions? Yeah, so the police stuff is actually quite difficult. That is why we actually do everything with. I think it's actually why the World Economic Forum set up that Atlas group in the first place. Is that for us to deal with the police ourselves is just too onerous a task on us, right? Because we're a reasonably small organization, and if we were just dealing with law enforcement, we actually wouldn't be able to pay our wages, right? So that's why World Economic Forum, as an example, there's other examples, set up like this platform that like they say, okay, so here's what we want you to give. And then you don't have to collaborate like with the Bitcoin guys to work out where the payments and stuff. You just centrally give us what we need centrally. We'll also have like the Bitcoin tracker guys here. We'll have, whoever else was there, Spy Cloud and stuff, right? And they kind of put it together in the middle, and then Interpol is part of it, so they're directly dealing with it to take the burden off us of trying to work out police protocols and exactly what they want evidence wise and stuff, right? Because that's what can kill. It can kill collaboration, right? It's like you're trying to do the right thing, but like the weight on you is too much. So like you need these kind of platforms to be able to centrally just throw stuff in and not like kill all your team members trying to collaborate with law enforcement, It's brutal, you know. Because we had a terrible issue in the States with the FBI field officers constantly contacting us for information on cases they're working on. We're going, we can't do this. We've got jobs to do, you know. Yeah, the Atlas Forum has been a good experience. So, I mean, they've had successful operations. Interpol, will put it out to like, so in that case, they put it to Afripol, but it could be with Europol or whatever, right? And they'll do major operations in each of the regions. So, compared to what was there years ago, yeah, it's definitely a big step forward. And like Europol now have been, they want us to deal with them as well directly, to do something uh, directly with them. And I think that's worth doing as well. Uh, but as I think they're all a lot more understanding nowadays as well of the burden that they put on you, as the kind of provider of the information, because there used to be no understanding of that, right? There was even, there was a lot of compliance laws like in Europe and stuff that was really, could kill the company, in terms of the burdens on the company as opposed to anybody else. So it's like you get punished for seeing the crime. Anyone else? Well, we're in the hall at the booth if anyone wants to have a chat about anything. Um, you know, it can be on a lighter note. Okay, thanks very much for having us. Cheers.